Okay, good afternoon. I'll try not to keep you too long so we can all get to lunch. But what I want to talk to you about is using these drives. Well, one thing to get out of the way, if you're expecting to hear about batteries, diesel, decarbonisation, you're in the wrong room. This is not what we're talking about. So moving on, I think it's this one. No, that's the green one. Okay, first off, what is a gearless conveyor drive? If you look at conventional drive, you have some sort of motor, coupling, gearbox, another coupling, driving a pulley. In a gearless drive, the only thing missing is the gearbox and one coupling. We have, instead of having a high-speed motor at some level of torque, we have a low-speed motor at a much, much higher torque. The mass of this combined mass tends to be similar to this combined mass, but you get the advantage of not having the gearbox. And what does not having the gearbox mean to you? Basically, you get four benefits from not having a gearbox. You save energy, because a typical gearbox is maybe 5, 6, 7, 8% losses. If you don't have the gearbox, you don't have to supply the energy for those losses. You have reduced installation costs. You've got no gearbox to mount, you've got a lot less coupling, so there's less aligning, there's less lifting, less cable, fewer pieces of equipment, less monitoring, and so on. So there's less pieces there. In OH&S, which is a big topic in some places, or in most places, because it's a more efficient system, there is less waste heat. There is less noise, which I'll talk about on later slides. And there is no flammable liquids, because there's no oil. And reduced maintenance. You don't have a gearbox to maintain, monitor, change the oil, and overhaul from time to time. Now we'll talk about each one of those things in not so much detail, but enough to, I hope, get your interest. And if you want to get some more details, I can tell you stuff about it offline if you like. How do you get your energy savings? This particular diagram is recordings from the first trial system we actually did. We had an installation where we put a doubly fed pulley, or a conveyor with a doubly fed pulley. We had a conventional drive on one side, excuse me, and a gearless drive on the other. We had torque transducers on the output shaft, so we made sure they were both delivering exactly the same torque, which is what this top line is. This is the torque on each of the motors, both the red and blue together. What's interesting here, these are the phase currents to the two motors. The red one is the induction motor, the blue one is the gearless motor. And there was 25% less phase current, and there's for two reasons. One is you've saved energy, so there's less current for power, but also the gearless conveyor motor in this particular size is very close to unity power factor. So you're delivering something like 20% less current to the motor to make it run. And then this down here is the power. You have less power delivered to the GCD than to the induction motor because it's not supplying the gearbox losses. And as I said, this was our initial test on a system which is still running in Germany. It should have stopped, but the Germans have extended the life of their coal mines for reasons we all understand at the moment. Wrong one. This is a cost comparison, or an estimation that was done to give you an idea of where you might be. This was for a 12 drive system, so 12 megawatts of power, 10 cents a kilowatt hour, 8,000 or 9,000 tonnes per hour. And what you would get out of this system, to give people an idea, you save energy each year. These are your energy savings accumulating over 15 years. You have less downtime because you have less potential parts to fail. Having less pieces means less failures. It's a less is more type game. And you have lower maintenance costs. On our trial system that we put in, which we shouldn't call it a trial anymore because it's been running for nearly 4 years, the total maintenance they invested into the gearless drive in 18 months was 1.5 hours of inspection. in 18 months. So this gives you an idea of what you can bet. And this is an operating expenditure game. It is not a capital expenditure. There is some CapEx savings with this system, but it depends very much on your installation. That one, no, that one. So how do we get you reduced installation costs? You have no costs associated with your gearbox, no mounting, no transport, no storage. Because you have lower cables, lower current, you have smaller cableways, smaller cables, less installation for those. And lower current means smaller drives, you have smaller switch rooms, smaller transformers, less feeders along the way. In underground, you also have some other benefits. This is a more compact system, so you may need a smaller cavern where you are putting your drive head. You may need a smaller access tunnel because of the compact nature of the equipment to get it down underground. There's less heat generated because it's more efficient, so you can potentially reduce your ventilation or your cooling if you're in an area where you have to cool your mine. That's why when you look at these systems, you cannot look just at the gearless drive. Gearless drives aren't cheap, I will get that out the front, but you have to look at your cost of ownership, not just the cost of your conveyor. This one. So what do you get for OH&S? The noise difference. Typical conveyor drive is something in north of 90 dB noise level, which is quite uncomfortable. These motors run less than 70 dB, which is basically living room noise. There'll be more noise from the idlers and so on, the rest of the conveyor, than there will be from the drive system. You have less heat in the area, so it's cooler. There is no oil, so you have no potential for spills, no potential for a fire, less manual handling, less transportation, and again, less equipment. And if you have less pieces to lift up onto the side of a conveyor, if you've got a drive head in the air, you have less manual handling, less potential for incidents. Gotta get it right. Reducing your maintenance costs. You'd have no gearbox, so you have no associated equipment. A lot of people forget it's not just the gearbox that you remove. A lot of the bigger gearboxes have oil pumps, they have monitoring systems, they go back into your SCADA system and your data gathering. All of that disappears because it's just not there to monitor. You have no oil, so you keep no oil in your stock up in your warehouse. You don't have to have a truck to transport it. You don't have to repair a gearbox. Maybe every 10 to 15 years you have to overhaul your gearboxes or replace them or something like that. Without the gearbox, you don't have to do that. The life of the permanent magnet motor we use, this is, by the way, I'll explain that in a minute. This permanent magnet motor has a life that's projected life in this application is at least 20 years between service intervals. So it's effectively a set and forget system. And because you're running this motor at maybe 70, 80, 90 RPM top speed, then there's less potential for vibration in the system. When I say a permanent magnet motor, these are a synchronous machine with a permanent magnets on the rotor. So there is no internal heating in the motor, there's no shaft heating in the motor. They're an IP 50 or 60 plus motor. We do them mostly IP 66. Totally sealed motor, so there's no dust ingress and so on in the motor. That helps the life. And basically that's what you're doing. People worry about, I've had a lot of people say, oh, this is new technology. We don't want to risk ourselves on new technology. Our mine lives around these main conveyors. These motors are not new. They've been used in marine applications particularly. They're used in other industries. They're not a special motor in that sense. It's not a new concept, it's just a new application. And miners tend to be conservative. To get people to try something a little different can be difficult. We have some installations, we're having other people interested, but getting that last hurdle is the hard part. But if you think about what you have in a normal system, you'll have switchgear, a transformer, a variable frequency drive, a motor, a gearbox and a pulley. The only part missing with this out of that is the gearbox. We still have the variable frequency drive, still got the switch gear, still got a motor. There's nothing special in it in that respect. It is the application. And this is an energy saving thing. In this application, one of the things we have that has not been talked about a lot at this conference, we're talking about removing diesel and so on from the mine infrastructure. Only a portion of the mine is running on diesel. Most of the rest of the mine is running on electricity, so already. So part of this is looking at where, if we're trying to get a greener world, going to this and reducing your energy consumption, using energy more effectively and not wasting as much, is what this is really pushing, why we're very happy with this. We have these motors available up to 3 to 4 megawatts in power. We can go larger, but typically the bigger ones we'll do is a conventional synchronous motor, a low-speed, high-torque synchronous motor for very big conveyors. And the smallest size we do in these is around the 100 kilowatt level. Below that, you're in such a low-cost market, it's very hard to get a return on investment. So, seeing I haven't even used much of my half hour, all in all though, this is what we have. You have reduced operating expenditure. You've got the potential for reduced capital expenditure. I have had some customers say they've done their numbers, and even though the conveyor, the drive costs more, their total cost of ownership is similar to a certain standard conveyor. You have reduced OH&S and reduced business risk because you have less equipment. Less is more. If you don't have it, it can't break, it can't fail in the middle of the night. And you get a better environment to work and a reduced load on your energy system. That is a gearless conveyor drive in a nutshell. And I think that's the end. So.
I have a question. Clearly, everybody's familiar with gearless drives in large sag mills, and that's something that's being done at many locations, both indoors and outdoors, and is, ABB's done a lot of those.
Gearless mills, yes.
Are there major differences in the technology, or is it essentially the same? What are the key differences, and what learnings from all the, those 20, 30 years of gearless drives in mills have you been able to apply?
Gearless mill drives are typically a ring motor that's built around the outside of the mill. This is just the way to think about these motors is they're a standard motor. Really, the stator frame of the motor is standard. It's just loosely standard. It's a wound stator of some sort in a frame with bearings. The only real difference is instead of having on the shaft having a separately excited poles and fields in there with slip rings or brushless arrangement, or have an induction motor with a squirrel cage, we just have permanent magnets that are permanently magnetised. So in a lot of ways it's a standard motor. Your clock at home on the wall probably has a similar motor in it. So it's not a new concept, it's a new application. If that answers the question.
Sure. Any questions from the audience? Up at the front here.
Good presentation. One question regarding to permanent magnet motors. They are basically a low voltage application. Which are the limit for the medium voltage?
Sorry, on the voltage levels?
Voltage level, permanent magnet motors are basically, or were up to some years ago, a low voltage application.
Yeah.
Which are the limits for the medium voltage?
We build these motors to they're not, custom's not the word I like to use, but they're standard motor designs, but we will change the voltage. We typically supply the smaller motors as a 690 volt motor, and then as you get bigger, maybe 1 megawatt, 1.5 megawatts and up, will be 3,000 volt or 6,000 volt motors. That's the voltage levels for these, if that's what you're asking.
Any other comments or questions? Yeah, there's one up. Christoph at the back, right.
You said that the motor lifetime is 20 years. What limits the lifetime to 20 years?
Bearings.
Okay, but you can exchange the bearings.
Change the bearings, yeah.
Okay.
Basically change the bearings.
Anything else? Okay, thanks, John.